Hi there. Behind me you'll see how the fan blades are being removed from the engine. Now let's take a look what exactly it takes for all these parts to be cleaned, inspected and repaired. Can you imagine what an aircraft engine must endure during its lifetime? From -60 degrees to when the aircraft's in the air, to 1,000 degrees once the fuel is being ignited and pushed through the turbine. From 30 to 35 bars of pressure once the combustion takes place. Then from hot and heavy environments such as deserts with ingestion of lots of sand and dust, to landing in Arctic winds and snow. From being switched on and off a couple of times a day. Therefore, a large variety of materials, coatings and systems are being used to withstand these harsh environments. From lightweight parts like composite parts and aluminum and titanium for structural application and weight saving, to heavy nickel and cobalt-based superalloys for the hot and loaded parts of the engine. In order to keep costs and TAT down and increase our flexibility, we need to have a high standard of capability on these parts. Well, we've got you covered.
In the moment we are in the cleaning shop where we're performing a cleaning of different engine parts. Those cleaning processes can be very simple and very complex, including the real chemical reactions. Cleaning processes are very vital and critical for accurate entity inspection.
With the eddy current robot inspection system, we induce an electromagnetic field in the material and scan it back for possible discontinuities in the material, such as cracks, voids and possible inclusions.
FBI is a method that uses capillary effects to penetrate the possible crack in the material. After removal of the excessive fluid, a developer is used to develop a car. After the development time, the part is inspected under UV light.
Having cleaning and NDT process complete, it is time to start our inspection. During this inspection, all geometrical and visual inspection criteria are being checked. If such defects are identified, imprint measurements provided with a 3D microscope are used to define the correct disposition. This provides transparency throughout, from the inspector, engineering, the manufacturer and the customer. Only on these data a correct disposition can be determined, which can be very cost sensitive.
Also der Wagen Rüsitz, der ist abgenutzt, den müssen wir aufbauen, der vorne dran auch. Machen wir einen neuen Chromprozess, der Turbine Pilot hier ist auch abgenutzt, den wir auch neu aufbauen. Bei uns in der Inspection prüfen wir Teile auf Beschädigungen, prüfen, auf kleine Nicks. Wir prüfen sie auf Maßhaltigkeit, prüfen. Die Sitze, die abgenutzt sind, können wir neue Chromen, blenden. Wir können in der Galvanik Nickel aufbauen, dass die Teile nachher wieder verwendbar sind.
This ensures the correct repair procedure is chosen for the restoration of the performance and build-up related features, the structural integrity. This guarantees the solid build-up of the engine.
After the vital process of masking the areas not to be coated, the plasma process heats up the coating powder to over a few thousand degrees into plasma. The powder is then sprayed onto the surface and cools down to form a protective layer on the base material.
During the plating process, parts are submerged into a liquid which contains the plating material. Using an electrical current, this material is deposited onto the part in order to protect the part or surface in question from corrosion, fretting, galling, seizing and buildup.
You want to know how we bring over 5,000 single parts worth over a couple of $1 million back into an operational engine? Then subscribe to our channel and keep updated on our journey of an engine.